Okay, this is sequence and series day number 1, introduction to those. In this chapter, you guys, every lesson will have some BC problems, some practice problems, and I'm going to work all of them out unless if they're just like kind of you look at it and you know. If there is some work involved, I will complete that and have it on the key. Let's talk real quick. We're going to skip this, but this is stuff that will typically relate to what we have been doing with some others mixed in for those BC questions. Let's talk arithmetic series. Okay, an arithmetic sequence would be 2, 4, 6, 8, etc. So we call this first term A, and we call it term number 1. The second term would be term 2, and that'd be A plus D. This is an example of an arithmetic series because the common difference, right, what it changes by each time, is addition related. So what is the common difference here? 2, right? What if it were 2, 4, 8, 16? Then it would no longer be arithmetic, it would be geometric. Those are the two types of sequences and series we'll be dealing with. So if I take and I add the common difference, and then I add the common difference again, my third term will be A plus 2D, right? And then I could continue on forever and ever. Let's say I go out to the nth term. What would this be? A plus what? N minus 1 times D. And that right there is how we find any term within a sequence, at least an arithmetic sequence. We take the first term, A, and we add N minus 1 times the common difference. So if I wanted the 20th term here, I would take the first term, which is 2, and add 20 minus 1 D's to them, which in this case D is 2. And so I get 2 plus 19 times 2, which is 38, which should be 40. Our 20th term should be 40. Okay, which makes sense, right? I'm adding 2 20 times. 19 times. I should get 40. Now, if I'm looking for the sum of these terms, I have 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16. Let's go out to 10. How many am I at? Plus 18 plus 20, right? That's the first 10 terms, I think. If I wanted the sum of the first 10 terms without actually adding them up, what could I do to shortcut it? The E thing, kind of. Well, what do you see that's true here? What's that equal to? 22. What's this equal to? 22. 22. 22. 22. All of those add up to 22. Okay, so how many 22s do I have? No. 5 of them, right? 5 of them. How many terms are there here, right? There's 10 terms. So here's how we come up with the formula, right, in order to determine the sum of the first n terms. We take n, which in this case is how many? 10. We divide it by 2, and we multiply it by the sum of the first and the last, right? If we don't know what the last is, then we use the previous formula to find it. So our formula to find the sum is n over 2 times a plus an, right? Which is our first plus our last times the number of terms over 2. That only works with arithmetic sequences, though, and series. Geometric will be different. So far, so good? Okay, a different way to write this, you guys, is there is an alternative form, and all that they do is they do this. They take A, and then they determine A sub n is actually equal to A plus n minus 1 times D, right? And then they combine these two to be 2A. So a different form that you might see and is useful in some cases, right, is 2a plus n minus 1 times d. Okay, but it's the same thing. It's the exact same thing. All right, I prefer this form right here. It just works easiest. But why would this one be useful? Someone just asked me this question. Why would this be more useful? Diogo? Yeah, if you don't know the nth term, right? If you don't know the nth term, then that's useful. All right, so if I told you to find the sum of the first 204 terms of this sequence, you'd be like, I don't know the 204th term, but I do know the first term, and I know how many terms there are, and I know the common differences too, and so I could go from there. All right, this is a problem that you can work on independently in a little bit here. I'm going to skip ahead to geometric sequence here. So arithmetic is addition, geometric is multiplication, also known as division in some cases. Our first term here is 3. We're going to call that A. Our second term here is A times what we call the common ratio. Right? And our common ratio here is 3. We're multiplying by 3 each time. Our third term is going to be A times R to the second. So what would our nth term be? AR to the n minus 1. Okay, that is our formula for finding the nth term in a geometric series. All right, and in geometric series, a lot of times you need a calculator, all right, because it's going to get, once we start going to the nth power, whether that be 10, which seems realistic and somewhat relatively simple, 2 to the 10th is a very large number. Right? Okay, so let's talk about the sum of those terms. I'm not going to go through the proof right now, but does anybody know what the sum formula is? A, first term, times, anybody? No? 1 minus r to the n over 1 minus r. Okay? 1 minus r to the n over 1 minus r. And actually it is written up there too. So now the sum to infinity you'd think gets really nasty, but it's actually pretty nice. Right? Because what does this thing go to? What does that thing go to if, let's say, r is less than 1? If r is less than 1, if I take the limit of this as n goes to infinity and r is less than 1, what will happen to this? Yeah, it'll go to 0, right? Or actually, it'll go to 1. Excuse me. It'll go to 1. It'll go to 1 because it'll be 1 minus 0, right? So this will just be a over 1 minus r. If and only if r is less than 1 and greater than 0, or if it's between negative 1 and 1. Right? If it's not, then the series will diverge and there won't be a infinite series or an infinite sum for that, right? Because if I do this, check it out. Someone said, what if it's not? What if r is 2? Okay, well, let's take a first term of 10. Let's multiply it by 2 to the n power and see what happens. Well, the first term would be 20. The next term would be 40. The next term would be 80. What's going to happen is I add all those up. Yeah, I'm not going to get an answer. But if it's 1/2, if f of n equals 10 times 1/2 to the n minus 1 or n power, right, I'll get 5, then I'll get 5 halves, then I'll get 5 fourths, etc. And it's pretty easy to come up with that sum because the sum to infinity will be a over 1 minus r. Well, a is 5, 1 minus r is 1 minus 1/2, and what's 5 divided by 1/2? 10. It's going to add up to 10. The infinite sum of that will add up to 10. That only works. Infinite sum only works for geometric series if r is between negative 1 and 1. Okay.